Watch a modern construction time-lapse, and you'll see a structure build itself with a satisfying, almost magical fluidity. Beams snap into place, walls rise in seconds, and a complex wooden frame blurs into existence without a single drop of sweat on screen. The audio track behind these videos usually reinforces this breezy vibe. A cheerful hum, a rhythmic ticking, maybe a casual beep, painting a picture of total ease and effortless progress. The ground here drops away into a vertical void. The site is a narrow sliver of soil pinned to the edge of a jagged cliff, suspended over a massive, deadly abyss. A 10-minute time-lapse lies by omission. By compressing months of grueling work into a few hundred seconds, it completely erases the terrifying physical reality of the terrain. It hides the absolute logistical nightmare of building on a precipice. To actually see the architectural marvel hidden inside this rapid-fire footage, we have to break the illusion. We need to pause the tape, step onto the dirt, and look closely at the extreme physics these builders battle, frame by frozen frame. Let's stop the clock at day 1. At 0 minutes and 0 seconds, there is no house. There is only a steep, empty slope of loose dirt, terminating in a sheer drop. Shifting topsoil will drag a standard concrete slab off the cliff. To survive, engineers use micropiles. Crews drive these high-strength steel columns deep, bypassing the sliding soil entirely and locking directly into immovable bedrock to create an unbeatable permanent anchor. With the foundation pinned down, crews then pour massive concrete retaining walls behind the site. These thick barriers act as a heavy shield, physically holding back thousands of tons of higher ground from collapsing onto the structure. This foundation functions as a deeply embedded defense mechanism, an engineered anchor point fighting a permanent tug-of-war against the weight of the mountain. Advancing to the middle of the build, the challenge moves from the dirt beneath the workers' feet to the open air above their heads. Most sites have flat land to stack lumber, stage heavy equipment, and safely maneuver vehicles. On a cliff edge, there is zero staging ground. You cannot pile excess materials, and there's no safe drop zone. Every single piece of the house must be delivered from above. Builders relied entirely on heavy cranes to suspend thousands of pounds steel and timber directly over the open air, lowering them piece by piece onto the tiny, precarious footprint. This top-down view illustrates the razor-thin margins involved. A crane operator must calculate the exact arc, counterweight, and swinging momentum for every load. Swing too fast, or misjudge the reach by a few inches, and the shifting center of gravity could rip the machinery right off the mountain. Meanwhile, the human crew waits at the drop point. They have to physically catch, guide, and secure these massive swinging steel beams while standing mere inches from a fatal drop. Constructing this home requires treating the site exactly like what it is, a high-wire aerial balancing act, where one misstep leaves you with empty air. Pushing forward into the framing phase, the skeletal structure of the home takes shape, and immediately it encounters a new, invisible enemy: extreme weather. A sheer cliff face acts as a massive natural ramp. When heavy winds hit the rock, the air doesn't just blow horizontally, it violently accelerates upward. In updrafts, a wooden frame acts like a massive sail. Hidden steel moment frames absorb and redistribute the wind's twisting energy straight down. Heavy-duty tie-downs then bolt this entire assembly directly into the bedrock micropiles, securely grounding the house. The finished home operates as an aerodynamic vessel. Every beam and bolt works to hold the structure down, resisting the constant atmospheric assault from the valley below. When we unpause the tape, the siding, the roofing, and the gleaming windows blur together into a pristine, finished home. It hides the massive physical struggle under a coat of fresh paint and a casual sign-off. The builders pack up, smile, and say, "Hey, thanks for checking out our video today. Hope you enjoyed it. Give us a thumbs up." The modern internet acts as the ultimate filter. It synthesizes months of dangerous labor, highly precise mathematics, and advanced geotechnical science into 10 minutes of relaxing, frictionless entertainment. But once you recognize the invisible forces at play, the deep bedrock anchors, the high-wire logistics, and the steel skeletons fighting the wind, the video becomes something else entirely. It sheds the illusion of speed, leaving behind a quiet, profound testament to human engineering.